coming to this problem, R1 resistance is 100 plus or minus 3 ohm. R2 resistance is 200 plus or minus 4 ohm. You are asked to find out the effective resistance in parallel combination, and the options given are 66.7 plus or minus 1.8, 66.7 plus or minus 3, 66.7 plus or minus 4, and 66.7 plus or minus 7. These are the four options. For finding out the resistance in parallel, you know the formula that we have to use. The formula that we have to use is 1 by Rp is equal to 1 by R1 plus 1 by R2. Then we could write 1 by Rp is equal to R2 plus R1 divided by R2 R1. Then we could write Rp is equal to R1 R2 divided by R1 plus R2. Then if you have to solve this, the method that I have given you earlier was R1 R2 divided by, replace this R1 plus R2 as X. And if we are replacing this R1 plus R2 as X, you could write this is in the form. Now this equation will be in the form Z is equal to AB by C. And if it is in the form Z is equal to AB by C, you know the formula. Delta Z by Z is equal to delta A by A plus delta B by B plus delta C by C. In this method, you could find out the value of delta Z, that is, you could find out the value of delta R2. That is, let me write that also. You could write delta Rp by Rp is equal to delta R1 by R1 plus delta R2 by R2 plus delta R3 by R3. Or it's not delta R3 by R3, it is delta X by X. The third term is X, therefore delta X by X. Okay, but this is not the correct method for solving this. Why this is not the correct method for solving this? For understanding that, you will have to go to this formula. We could use this formula to get this formula only if the variables are perfectly independent of each other. That is, you could use this formula, that is delta Z by Z is equal to delta A by A plus delta B by B plus delta C by C, only if A, B and C are perfectly independent of each other. Perfectly independent of each other. In this situation, in our Rp is equal to R1 R2 divided by X situation, you could understand R1 and R2 are perfectly independent of each other. They are not depending on each other. But X, it is actually R1 plus R2. X is actually R1 plus R2. Therefore, X depends on R1 and R2. X depends on R1 and R2. Therefore, we cannot use this formula in this situation. Or this formula cannot be adopted since X is depending on R1 and R2. Then how to solve this problem? For explaining that, let me create some space over here. For explaining that, initially you have to understand what is d by dx of 1 by x. D by dx of 1 by x, as we know, it is d by dx of x raised to minus 1, and that answer will be minus 1 x raised to minus 1 minus 1, that is minus 2. That is minus 1 x raised to minus 2 can be written as 1 by x square, therefore minus 1 by x square. Therefore, now we know d by dx of 1 by x is minus 1 by x square. Then let me write this equation over here once more. 1 by rp is equal to 1 by r1 plus 1 by r2. We have to take the partial derivative of this equation. We will have to take the partial derivative of this equation, that is, what is d by the derivative of 1 by rp? What is derivative of 1 by rp? Derivative of 1 by x is minus 1 by x square. Therefore, derivative of 1 by rp will be minus 1 by rp square. But since it is partial derivative, you will have to add a drp over here. Partial derivative is a concept that you are not learning in plus 2 max also. After plus 2 you will learn about partial derivative. Therefore, I am not going to say any details about partial derivative. This is how we are taking the partial derivative. Only thing that you have to understand is you just do the normal differentiation. After doing that normal differentiation, put a d of that physical quantity. Then in this physical case also, what is derivative of 1 by r1? Derivative of 1 by x is minus 1 by x square. Therefore, derivative of 1 by r1 is minus 1 by r1 square into, you have to write a d of r1. In this case, we were writing d of rp. In this case, you have to write d of r1 plus, in this case, what is derivative of 1 by r2? It is minus 1 by r2 square. Then you have to write a d of r2. This is how you are taking the partial derivative. Okay. Then you could clearly see there is a minus sign over here, there's a minus sign over here, and there's a minus sign over here. You get this minus sign from the RHS and you could cancel it with the LHS. Then it will become DRP divided by RP square is equal to dr1 divided by r1 square plus dr2 divided by r2 square. Then this drp, it is small change in rp, or it could be written as delta rp divided by rp square is equal to delta r1 divided by r1 square plus delta r2 divided by r2 square. Okay. Then if you are writing delta rp, it is then rp square into delta r1 divided by r1 square plus delta r2 divided by r2 square. Okay, then let's finish it over here. Delta rp is equal to, what is rp? I'll give you a shortcut for finding out rp. In this case, all options are having 66.7 as the true value or the rp. Therefore, either you could find out rp by substituting in this formula, or you could directly write the value of rp in this case will be 66.7, since all the four options are having rp as 66.7. Therefore, let me use 66.7. 66.7 the whole square into, what is delta r1? R1 is 3. 3 by r1 is 100. Not r1, it is r1 square, therefore 100 square, plus delta r2 is 4, therefore 4 divided by r2 square means it is 200 square. Then you could write 66.7 the whole square divided by, from this two terms you could take a 10 raised to 4 out. 100 square there will be a 10 raised to 4, and 200 square there also will be a 10 raised to 4. 10 raised to 4 is taken out, then it will be 3 by 1 plus 4 by 2 square is 4, like this. Then it is 66.7 the whole square divided by 10 raised to 4 is 10,000 into this will become 3 plus 1. It will become 3 plus 1, that is 4. You will get the answer by simplifying it. You will get the answer as, yes, I think it is 1.77 something. You will get an answer like this. Then your answer for delta RP, it should be 1.77 something, means it is 1.8. 1.8 is delta RP. Therefore, this is your correct option. Now, I hope that you have understood this problem. Okay.